Okay, so with vectors, this is vectors that happens in year 1. You will come across vectors again in year 2 when you're doing year 13 vectors. So these ideas will be revisited, but they will be extended and made trickier. So it's important that we remember as much as we can from this ready for year 13 as well, okay? So I've put out a few different points that we need to know already from GCSE. If you don't know them already from GCSE, they kind of make a lot of sense. I'm just going to talk through them now as a bit of a refresher. So point A, whereas a coordinate represents a position in space, a vector represents a displacement in space. So it doesn't actually represent where something is, it represents how something is displacing, how something is moving in space. And a vector has got two properties. You probably know this already. A vector has a direction and it has a magnitude. This word magnitude, whenever I use the word magnitude from now on, I am meaning how long the line is of the vector. If P and Q are points, then PQ with an arrow drawn above it is the vector between them. Okay, that's some of the language that we're going to be needing to use here. Here's the point P, the position P. Here's the position Q. The vector PQ is the distance and the direction between those 2 points that we've got there. Letter B. If two vectors PQ and RS have the same magnitude and direction, they are the same vector and they are parallel to each other. So here is PQ, here is RS. If the vectors have the same magnitude and direction, then they are exactly the same. They are parallel to each other as well. Now this might seem really obvious what I've written here, but some students often think that the vectors must be different because the movement occurred at different points in space. That is not true. Although PQ and RS are clearly occurring in different places on my board here, they are still the same vector because they describe the same distance and direction. They are not in the same fixed place in space, but they are the same vector. It sounds like it's a subtle kind of bit of meaning that we've got there. Okay, point C that we have. AB is equal to minus BA. And the two vectors are parallel. They are equal in magnitude, but they are in opposite directions. So to go from A to B and to go from B to A is the same vector, but just made negative, because the negative is talking about a direction that something is going in here, okay? The triangle law for vector addition says that to go from A to B, which I actually should have labelled here, to go from A to B, and then to go from B to C, is the same thing as going from A to C. So I should have labelled that this vector is A, this vector is B. So if you add those bits to your diagram, it should say that to go from A to C is the same as going from A to B plus B to C, and those two bits are being added together, so you get A plus B. And it says here, the vector of multiple vectors is known as the resultant vector, and you will come across this in mechanics. So the resultant vector of A and B is A plus B. It means the result of them being added together. Hopefully these are things that you came across in GCSE, right? These are things that should be quite familiar from GCSE. Vector subtraction is defined using vector addition and negation. So instead of saying we're going to do A subtract B, the actual meaning of that is that we're going to do A and we're going to add on a negative B to that. So for this vector that we have here, which is A, and this vector which is B, instead of doing A take away B, we're going to do A and we're going to add on a negative B, which gives us A minus B. Minus B, how have I come up with what minus B is? It's the same vector, but it's just been going in the opposite direction. So you can see A is coming along and then we're coming down in B. F, very obvious point here, but it says the zero vector, which is a 0 and it's typed as a bold 0, it represents no movement. So here we've got PQ plus QP equals 0. We'll just have a quick think about why that's true. If this is the point P and this is the point Q, well, the vector PQ goes from P to Q, and if you add on QP, you're going from Q to P. You've ended up where you started, so there's been no movement at all, okay? And in 2 dimensions, the 0 vector is 0, 0. You've probably come across vectors like this when you were doing translations and things at GCSE as well. Point G, a scalar is a normal number which can be used to scale a vector. So that's why it's called a scalar, because it scales it. The direction remains the same when you scale something, but the magnitude will be different unless the scalar is 1, because when you multiply by 1, things don't get any bigger. So for example here, if this is our vector A, if you scale it by 2 and you get 2A, it's the same direction, but it's twice as long. If you scale it by -1/2, it goes half the magnitude, and the negative minus part of it makes it flip direction, which is obvious that we said earlier, if you have one vector and you have the minus of that vector, it's actually just reversing the direction because you're multiplying by -1. Last of all, point H, any vector parallel to the vector A can be written as, this letter here is called lambda. We'll talk about this later on in the lesson, so don't worry about it much just yet. Can be written as lambda A, where lambda is a scalar. It's just a Greek letter. What this means is if we can write one vector as a multiple of another one, then we can show that they are parallel to each other. So for example, if there was a question, and in the question it said, show that 2a plus 4b and 3a plus 6b are parallel, well, we could say that 3a plus 6b is 1.5 or 3 over 2 times a plus 2b, which means it's parallel because this can also be written as, I should have written underneath, that 2a plus 4b is 2 lots of a plus 2b. So we can see here 3a plus 6b is a multiple of a plus 2b. 2a plus 4b is also a multiple of a plus 2b. So they must be parallel to each other, because it says that if vectors are parallel, they can be written as a multiple of another vector. Again, we are going to look at these in some examples as well. Yeah, Arisa? Yeah, why is it 3 over 2? That's absolutely true. So that shouldn't be there at all. So we've got 3 lots of a plus 2b and 2 lots of a plus 2b. Yeah, very obvious there, sorry. So that shows that they should be, they're both multiples of a plus 2b. If they are a multiple of a plus 2b, then they are parallel to each other and they're parallel to a plus 2b. All 3 of those vectors are parallel. I think what I actually meant to originally type was that 3a plus 6b is 3 over 2 lots of 2a plus 4b, which shows that 3a plus 6b is parallel to 2a plus 4b because it's a multiple of that one. So you can directly show that this vector and this vector are parallel to each other. So that front page, if you get stuck in a particular question and you're like, hang on a second, I don't really know what to do, look back at this front page and it might have some of those hints of what you need to do to be able to solve the problem that you're looking at. Okay? So I've got here a diagram. I'm going to do the top one and I'm going to start the second one off and you're going to finish it for me. This one is going to be using, which point is it going to be using? It's going to be using D. It's going to be using rule D, which is the triangle law for vector addition, mostly. So I've got a random diagram that's been drawn here, and it says, in the diagram, PQ is equal to A, which we can see on the diagram, QS is equal to B, SR is equal to C, and PT is equal to D. Notice the direction from P to D, the arrow is also going in that direction as well. So part A says, what is the vector QT? Well, the vector QT, to go from Q to T, I actually can't go directly from Q to T. So instead, I have to go from Q to P, and then I have to go from P to T. Well, to go from Q to P, what's Q to P? It's minus A, and P to T is D. So we actually get D minus A for part A of that question. Notice when I'm doing my vectors, I'm underlining them. I underline them to show that it's a vector. If I was typing, like they do in the textbook, they make it bold, but I can't write in bold. No one can write in bold. So what we do is we underline it instead of typing it in bold. What about PR? Who thinks they can describe how we go from P to R? Nabil? Yeah, good. It's just going to be A plus B plus C. I haven't bothered writing out the whole thing there in that full way that we've done previously. Now we're going to come up with T to S. Who thinks they can say how we go from T to S? Shahan? Good. Minus D plus A plus B. Minus D plus A plus B. Probably what we would do is write that as A plus B minus D, just so we have it in that kind of order. That's actually quite interesting, because if we're going to do A plus B minus D, that's actually saying if you go from T, if you go along A, and then you go along B, and then you go backwards D, you still end up at S. Even if you take the vectors in a different order, you'll still end up at the same place, which is quite interesting. You don't have to follow it along the pathways. You can actually do it in any of those orders. What about the last one that I've got here? If I'm going to look at D, which is TR, Mabel, what do you think you could do to go from T to R? Yep. Yep. Good. So it's A plus B plus C minus D. So we've then got a second question. ABCD is a trapezium with AB parallel to DC, and DC is 3AB. M divides DC such that DM to MC is 2 to 1. AB is A and BC is B. Wow, there's a lot of information there. What do you think we would need for this to be able to try and work out any of the answers? A diagram. Okay, so we've got a trapezium, and it says that AB and DC are parallel. So if I just do a little sketch, we know that the AB part is parallel to the DC part. So it goes AB, C, D. And it wants the DC part to be 3 times longer than the AB part. So I'm actually now going to do a bigger diagram. So I've got A, B, C, D. Notice when I wrote the letters, I go A, B, C, D. I go around the shape in the correct order of the alphabet. I don't go A, B, C, D. I follow around the outside of the trapezium. And I'll also have made the bottom part of the trapezium 3 times longer than the top part of the trapezium because of this sentence that it says here. It says M divides DC such that DM to MC is 2 to 1. So roughly where do I need to be putting the M part? Closer to the C, like this. So this is where M is going to be. And it tells me that AB is A. So, and it also tells me that BC is B. What do I know about the vector from D to C, and why do I know that? It's 3A, and why do I know that? Because it's 3 times the length of AB, and there's something else that means and it's parallel, which means if it's parallel, it's a multiple of that one. So the whole thing is 3A. So what must the vector be from D to M then? Good. That bit's going to be 2A because of the ratio 2 to 1, and M to C must be A. Now we've got enough information. I'd like you to just very quickly work out A, B, C, and D, and then we'll come back together and work those out. Now you've got the diagram, see if you can work out what those ones are. No, but it's better to underline them. It's always better to underline them. Make sure you're underlining your vectors, please. Okay, let's start gathering some of the answers. If you're still writing them out, that's absolutely fine. But we're going to start off by looking at the vector AM. Red one, what did you get for the vector AM? Yeah, B. But before you did that, I'm guessing you had A plus B minus A. So you've got A plus B minus A, which just works out as B. Now, what's the significance of the fact that the vector AM is B? What's interesting about that? If there is anything that's interesting about that. Yeah, AM, the vector AM and the vector BC, not only are they parallel, but those vectors are identical. If you were going to be stood at A and you wanted to get to M, you would take the exact same journey as if you were stood at B and you wanted to get to C. So actually, yes, they're parallel, they're the same length, they are therefore the same vector as each other. So it allows us to see some patterns in some shapes that we've got. Okay, let's have a quick look then at BD. Taylor, what did you get for BD? Good, it's B minus 3A. And that's to go all the way from here to here. That is B minus 3A. So the purple arrow represents the resultant vector of B minus 3A. Tameen, what did you get for C, which is MB? So MB is A minus B. And if I were to draw that on, it's just that vector, because you're going A minus B. And then our last one, Amina, what did you get for DA? How much was that, sorry? 2A minus B. Okay, good. So you have 2A minus B. The long way of that is being 3A minus B minus A. But actually, we can now see, because of this vector that we said, which was blue, which was B, it's just 2A minus B. So this bit, which is DA, is the last vector that we've got on there. It's just 2A minus B. We are really quickly going to squeeze in one example of me doing a GCSE question, and then you're going to do a GCSE question, and I'll leave you with a bit of homework to do for this, okay? These topics we've done recently have been really short, which is why we haven't done many like problem-solving stuff on the boards, but we will do those soon. Okay, so this was from the GCSE paper in 2013. It was the last question in the exam paper. I don't think it's that hard though. I think it's the last question, question 27. So let's just quickly read through. It says PQRS is a parallelogram. Notice how it goes PQRS. It follows around the outside of the shape. N is the point on SQ such that SN to NQ is 3 to 2. As soon as I have that, the ratio wasn't actually on the original bit. I like to add the ratio in as a bit of a visual aid. So SN to NQ, the ratio of SN to NQ is 3 to 2. So I like to add on that ratio is 3 to 2, and I'd recommend you doing that as well. It tells you that PQ is A and PS is B. Write down in terms of A and B an expression for SQ. So SQ is just trying to go from here to here. But instead of doing that, I'm going to go along here, and then I'm going to go along here. So very clearly for that 1 mark question, it is minus B plus A, but you need to be in the habit of rewriting that as A minus B. The other way that we could have seen that is we could have recognized that to go from S to Q, I actually could go that way and that way. this vector is A in that direction. That vector going upwards is B, so it's still going to be A minus B. The reason I knew that that one was A and that one was B is because they're parallel. It's a parallelogram, so they have to be the same as each other. Part B of the question, though, maybe there's something slightly different in there. Part B of the question says, find what NR is. So we're going to try and express what NR is in terms of AB. Now, if I'm trying to go from N to R, I'm going to take the journey to go here, and then I'm going to take the journey to go up here. That's what I'm actually going to try and work out to try and go from N to R. How do I go from N to Q? Good. So I'm going to go from N to Q, and then I'm going to go from Q to R. So that's 2/5 of A minus B, which is 2/5 of SQ, because that's the fraction that I'm going along of that part, and then I'm going to add on QR. So it is 2/5 of A minus B, and I'm going to add on QR, which is B. So I get 2/5 A minus 2/5 B plus B. So it's 2/5 A plus 3/5 B, which you may like to factorize out the fifth and get 2A plus 3B. Okay, so you've now got another GCSE question that's at the top of the other page. You can have a go at answering that GCSE question, and then you've got a few questions that you'll do for homework for me from exercise 11A.